I'm audible, right?
Yes, sir. You are.
So, hi guys. So, today we'll be focusing on module 3, and I would say the first 75 to 90 minutes we'll discuss module 3. After that, after break of maybe 5 or 10 minutes, we'll start solving sample questions from the sample paper, close to 24 questions, all questions from module 1, 2, and 3. So that's our main agenda today. So I'll start with the first part, module 3. So module 3, we have the chapter is predictive analysis. So let's start. So before that, let's look back and revise all the concepts we have learned till now. In module 1, which is parametric and non-parametric test, we have majorly discussed 3 topics, right? Number 1, chi-square test for independence. Number 2, goodness of fit test using chi-square test. Number 3, Wilcoxon sign rank test. These were the 3 major topics. And in module 2, it was advanced regression. First, we learned about linear regression, the assumptions of linear regression. Secondly, we learned about logistic regression. And under logistic regression, we've learned log, log odds, and like the main problem. Yeah, the main problem or the finding the probability using logistic regression. And lastly, we've discussed about nonlinear regression methods such as polynomial regressions, power regressions, etc. So module 1 and 2, so module 1 and 2,
नहीं
you can see
हाँ
who's that actually. Shreya, can you just mute yourself? So module 1 and 2, like it was not a connected module. Look, like even if you haven't watched any module, I mean any sessions of module 1, you would be able to like get the concepts of from module 2. But module 2 and module 3 is somehow connected. Like we are having the same linear regression, logistic regression in module 3. So I won't be diving deep into those topics as I did before, but I'll be briefly explaining those topics just for the context to build that context. So I think this is what we have learned till now, module 1 and 2. We are focusing on predictive analysis in module 3. So these are our main agendas. We have 7 main topics. First one is forecasting. It's a theoretical topic. It's easy. Linear and logistic regression, almost similar to what we have learned before. Yeah, we'll briefly discuss about those two. Fourth one, confusion metrics. It's an important concept. I think at least one question will be there. So it's a practical concept. Time series analysis and the practicals, both theory and practicals. So we'll be doing some questions while the discussion, and after that, in the sample paper 2, we'll be having questions. And last is mostly a theoretical concept. I won't be diving deep into that, but I'll briefly explain about auto-regression and auto-correlation. So in module 2, we had like a lemonade seller, right? So in this module, I thought of changing it. So here we have a tea seller. So yeah, as you know, like he sells tea, but the unique factor about him is that he is someone who take note of every sale he makes. So he know how much sales he have made in November, December, January. So he know that. So he started looking into the past data, what he have. So in December, he sold like 8 cups of tea. And in January, he sold like 10 cups of tea. He's looking at the data, he's analyzing it, he's trying to interpret something out of it. So he can use those conclusions for making future decisions. So while he was thinking, like, yeah, in December I sold like 8, in January I sold like 10, using this data, he made a assumption or a prediction. Fine. So I'm repeating myself. The module we are learning is predictive analysis, right? So he made a prediction. He has some data, he made a prediction. The prediction was that in February, I'm going to sell 12 cups of tea. Fine. So what was the whole process? He recorded the sales from December. He know that December he sold 8 cups, January he sold 10 cups. So using those data, he made a prediction that in February, I'm going to sell 12 cups. This is forecasting. Forecasting is basically predicting future values based on historical data. Here, what we have the sales data, right? We have the sales data. So using that, he made a prediction. So basically, this prediction can be in 2 ways, right? So he predicted the data for February. He can either do it for like March, April, maybe even if he have more data, he can even predict for maybe next year. So prediction can be for short term or for long term. This is basically forecasting. Forecasting is the process of predicting future values based on past data. Simple forecasting can be either for short term or long term. Done. This is something like I've explained this just to build that context. So I will build up things with this context. Types of forecasting. There are n number of forecasting. Like the example we discussed was sales forecasting, right? So he had some sales data. Using those data, he predicted the sales. If let's assume our example, our statistics exam is coming up this week. So using our past statistics marks or marks from term 1, we can predict the marks of term 2. Let's assume that. So this can be, we can call this as a maybe marks forecasting or grades forecasting. So there are like n number of forecasting. Here you have demand, financial, sales, marketing, workforce. So this is what simply you have some past data. You're using those data to make future decisions. Simple, done. Forecasting methods. This is where our actual like whole concept begins. So we have 2 major forecasting methods: regression methods and time series analysis. We are aware of this regression method. We have already discussed that. So regression method, we are basically using the linear and logistic regression to find to predict about the future, right? We'll dive deep into time series analysis later. So we'll start with the regression methods. Right. Linear regression. We have already discussed this, but still, for linear regression, there will be an dependent variable and an independent variable. So let's assume here, let's assume the independent variable is temperature. So in this case, as temperature increases, his sales will drop, right? So if temperature moves from 30 to 35 degrees, it's more hot. People mostly prefer like some cold drinks or some juices. So people doesn't prefer tea much, right? But as the temperature decreases, it's cold. So people mostly prefer what, tea. So basically, this Y is the dependent variable, which is the sales in this case. X is the independent variable, maybe the temperature, right? So we now know like a relationship these two have, right? As X moves, as I mean, as X increases or decreases, there is a change in Y, right? Beta, beta is the coefficient of X. This is an error term and this is intercept. These two terms, I would say, you just be aware of the names. This is intercept, this is error. For like a practical problem in exam, you will get all the values. You will get beta 0, beta 1, x1, error term, and they maybe ask you to find the one. They'll ask like predict the sales, given that the temperature is XYZ, beta is ABC, beta 0 is PQR. So you just need to put those values into the equation, you get the answer. Simple. That's it. Linear regression is a method to model relationship between one or more independent and a dependent variable.
Can't wait to see how this game works. Oh man.
So let's assume we have 5 data sets, right? And I've divided this data in sets into 2 parts. We have already discussed this also in module 2, but still, I've divided this into 2 parts. One part I use for training and the other part I use for testing. The conclusion that I get from the first part, I use it in the second part. This is basically cross validation. And if we have a k number of, like here we have a fixed number, right? We have 5 data sets. So this we call k-fold cross validation. So what is k-fold cross validation? We have some data, k number of data. We divide that into 2 parts. One we use for training, first step. The second part we use for testing, and this is majorly used to find whether the assumptions are accurate, just to check the accuracy. So here we have the definition. So K cross validation is a model evaluation technique that split the data into K equal parts, trains the models on K minus 1 parts. Make it simple. You have a data, you divide it into 2. One you use for training, the other one you use for testing. That's it. The goal is to evaluate the model's performance. Fine. We have discussed cross validation in module 1, module 2. This is k-fold cross validation. The number of data sets are fixed. So k equal parts. So here we have 5 data sets, k minus 1 data sets. So that is 4 data sets we are using for training. The other one we are using for testing. So we do this process for all sets. So in the next, maybe in the next session, like this data will be part of the training data, and one among this will be a testing data. So we'll basically get a good model, good accurate model to predict. This is k-fold cross validation. So till now, we built the context, that is what is forecasting, predicting future value or future with or using past data. We discussed forecasting, we've discussed linear regression and k-fold cross validation. Evaluation metrics. I'll briefly explain this. I won't dive deep into this. So let's assume I have an value, an observed value. This month the sale was 100. I predicted 90. What's the error? The error is 10, right? So this error, we can like find the accuracy and effectiveness of these regression models. So there are basically 4 types. Mean, absolute error. So you just be aware of the terms and you just be aware of what is it. Mean, absolute error, just we take the average mistakes. We take the error terms and we average it out. It's a wrong, just it's a mistake that we made. Mean squared error. So average of squared mistakes. So we square the errors, so the data will be so huge. Like we portray the mistakes as big mistakes. Really angry at big wrongs. Root mean square error. Square root of MSE. MSE is mean squared error. You just be aware of this. I don't think whether it's important or not, but you just be aware of this. Square root of MSE, a friendly version of MSE, since we are taking the square root. R square. R is basically correlation coefficient. We square it out, how well the model fits. Basically, it shows us how well the model fits. If it's 0%, it's bad. If it's 100%, it's perfect. So this is basically evaluation metrics just to assess our errors. Fine. Just be aware of these terms. I don't think it's that important. Just be aware.
Rishabh,
Yeah.
can you please explain that second one? It said that really angry on big term, something like that.
This one.
Yeah, second one. Really angry at big wrongs.
Uh, mean squared error. So we have an observed value. We deduct the expected value from it. There is an error. We square it out. So let's assume if the error is just 100, while squaring it becomes 100 into 100, 10,000. So we portray basically it as a big error. So big errors will be portrayed as like in a large with a large number. So it's just for context that like really angry at big wrongs. So once we square big numbers, we get a bigger values. It portray as a big error we made, right?
Okay.
Logistic regression, even this we have discussed in module 2, but still I'll briefly explain this. Basically, what is linear regression? There is an independent variable, temperature. There is a dependent variable, sales. We have numerical data, right? Temperature 70 degrees Celsius, sales will be 100. So we have numerical data. Let's assume the same case, the T seller doesn't have any data. So he is like, is this a sunny, is today a sunny day? Yes or no. Is it raining today? No. He have answers like this, categorical answers or categorical data like yes, no, success, failure, etc. So for this kind of data, we don't have any real numbers, but we have some answers, right? Some fixed answers we have. Using these answers, we predict the sales. Simple. Using these binary data or categorical data, we predict the future sales, or that we predict the probability of happening that event or something. Like if let's say I'm saying if temperature, like if it is a sunny day and if there are more people on the road, I have yes for both the questions, my sales will be high. So I'll find the probability of this kind of a scenario. Simple. So unlike linear regression, logistic regression predicts probability. Basically, in linear regression, you will get values. It can be from, like I guess, negative infinity to positive infinity. Values can be anything. But for logistic regression, the values are restricted to 0 and 1, right? Because it's probability. So maybe you will get 50%. So there are 50% chance that this kind of a case happen. That's logistic regression, simple. This is the equation for logistic regression. We'll do a question. Yeah, we'll do a question for both logistic and regression, linear regression. Then we'll proceed to next. Harshit, is my Google Sheet visible?
No,
Yes,
it's still
it
the
is.
slides.
It is?
No, it is not.
Is it visible now?
Yes, Mr.
Yeah, it's visible.
Yeah, fine. So we have an equation for linear regression. We have the equation for logistic regression. We have a question. So we'll do it. A company wants to predict, right, whether an employee will be promoted. Fine. Based on the number of years of experience, the company collected relevant data and implemented logistic regression, which led to estimated coefficient of, no, as I said, all this is beta 0, B0, beta 1, B1. These values will be given. So we have to find slope parameter corresponding to S. Yes, this is that. This is intercept. What is the probability that an employee with 6 years of experience? Fine. 6 years of experience. This is what we need to predict whether an employee will be promoted, right? That is the dependent variable. Amit, can you just mute yourself? So basically, we need to predict whether he will be promoted or not. So what you will notice one thing here. Here we have the equation for linear regression. Same part we have for the logistic regression as well, right? So we'll first do this. Just a second. No, actually in the question they are asking logistic regression, but still we need to find this, right? So basically we are finding the linear regression. So let's find that first. Linear is equal to beta 0, which is 0.3, plus we have beta 1, 0.2, into what's the value of x? What's the value of the independent variable? The value of independent variable is 6. So we'll multiply it by 6. This is what? This is a linear regression value, right? Now we'll find the logistic regression. Yesterday, like the day before yesterday, someone told that, like, actually there are 2 equations for logistic regression, and I'm using a long one, right? There is one equation like log odds or something. Just a second. No, someone mentioned like there is also another equation, like we have to find the log odds or something, and then we can easily find the answer. Yes. So basically what it is, log of odds is equal to beta 0 plus beta 1 into x1 till beta n into xn. So basically, simply we can say that log odds is equal to linear regression. So both values, basically what they are doing is they do, instead of this equation, they'll do e raised to minus log odds, which is equal to the same equation, right? So we'll complete this first. So we have this value. We know that log odds 1.5. Now we'll find the e raised to x value. So here we type, it's minus, right? E raised to minus x. So we'll first type minus 1.5, click on the enter button, we'll take the exponential e raised to x. This term right here, e raised to x. We get 0.223, right? So here, so what's the equation? 1 divided by, this is the logistic regression equation, right? 1 divided by 1 plus 0.223. This is the exponential value. This is part of the equation. We get 817. So this is what? This is a probability that kind of a case.
So,
will
bro,
happen.
could you explain how you got E's value again using the calculator? Like what function did you use?
Yeah, using the calculator.
Yeah.
Okay. So again, I hope if the software is of TCS Ion, we'll be getting the same software. So we need to find the minus exponential, right? Negative exponential. So first we'll do negative, then we'll do minus 1.5. We entered the log odds value or the linear regression value. We click on equal, so we get minus 1.5. So this, there are many, like we have exp. Yeah, there are basically two e raised to x. So you might get confused. You just be aware of, like, we have to use e raised to x, this one right here. So once I click this, I'll get the answer, right? One thing is that if I do minus 1.5 e raised to x, the answer is different. It's because I've not clicked on the enter button. So it will go like 0 minus 1.5 e raised to x. So if I click the enter button, it will become minus 1.5. I'm taking exponential of the same. Then I'll take 1 divided by 1 plus 0.223. 0.817. So the logis probability of y is equal to 0.817. In percentage terms, we can conclude that there is 81% chance that if an employee works for 6 years, he will get promoted. That's our conclusion. So we've solved both linear regression and the logistic regression in this question itself. Fine. Next will next,
Rishabh, does there any question exist where only linear regression is supposed to be used?
can you come again?
I mean, will there be any question where only linear regression has to be used and not logistic? I mean, is that possible?
I'll explain once more.
I'm asking that, like here you use logistic regression, and will there be any question where only linear regression is supposed to be used? Because, I mean,
Yeah, there can be. There can be. Yes.
because then the answer will be some value, right?
Yeah. This will, if the same question they ask for linear regression, what will be the value? 1.5. Right. So this value, we need this, anyway, we need this value to find logistic regression, right?
Yeah.
So there can be questions, yes, there can be.
Okay.
So we have finished logistic regression. Basically, we have discussed the what? Forecasting, we have discussed full theory, basic concept. After that, we have discussed what? Linear regression and logistic regression. If you know the equation, if you know the basics, done, right? Put the values in, you will get it. Just be aware of which, like the button you have to use on the calculator, right? E raised to x, that's it. We have also discussed about the k-fold cross validation, basically dividing a data into two parts, one for training, one for testing, why it is used for better accuracy. Next, we'll dive deep into confusion metrics. So this is an interesting part. There can be a, I think I've already mentioned, like there can be minimum one question from this side. It's simple. We have like a table, there will be a table given, and there are like 4 questions that you can expect. For those 4 questions, there are like 4 equations. If you know that, you like put the values, you'll get the answer. That's it, simple. So this is basically the confusion metrics. I'll briefly explain what the logic behind these are. So this is true positive. TP is true positive. This is false negative, false positive, true negative. So what does this represent? I predicted yes. Fine. I predicted positive. In reality, it was positive. So it is true positive. Fine. I predicted no. In reality, it was yes. So it is false negative. Fine. The assumption was basically wrong. I've predicted no. So it was false negative. I've predicted yes, but it was actually no. So false positive. Positive, why? Because I predicted yes. False, because the actual prediction, I mean, the reality was wrong. So false positive. And this is what? Yeah, true negative. So in reality, it was no, and I've predicted the same no. So it is true negative, right? This is important. This is so important. You must know like these values, TP, FN. You can like make the, like, remember this is a diagonal, TP, TN, FP, FN. These two diagonal, TP, TN, FP, FN. So using this confusion matrix, we can find 4 variables. One is the precision. First one is the accuracy, precision, recall, and an F1 score. These are the equations. So if you know the equation, there will be a table given like this. You know this is TP, this is TN, this is FN, this is FP. Just be aware of this equation and you will get the answer. That's it. Simple, basic maths. So accuracy, what is it? TP plus TN, TP plus TN, because these were 2 predictions which were right? So TP plus TN divided by total, like TP plus TN plus FP plus FN. What is precision? TP divided by TP plus FP. Come downwards. TP divided by TP plus FP. Precision. Third one is recall. TP divided by TP plus FN. So first one, it was TP true positive plus true negative divided by total sum. Fine. Second one is true positive divided by the first what? Column. Third one, recall, is TP divided by the first row, sum of first row. And fourth one, we have F1 score, which is 2 into precision into recall divided by precision plus recall. First, we have to find these values, then we'll put those value here, and you will get the F1 score. These can be the 4 expected questions from this confusion matrix. quite simple, right? You just need to know like what is TP, where is TP, where is TN, and maybe it will be given in the question, but better you know those things and just be aware of these equations too. You are sorted. So here we'll do, as I said, what is accuracy? TP plus TN divided by total sum, right? Fine. For these two equation here, we have in the numerator part, we have TP itself. Denominator for the first precision one, first column, and the second we have first row. Fine, simple. F1 score 2 into precision into recall, precision plus recall. So we'll do a question from this too. So we have a table here. Simple 50 TP we have, TN we have, FN we have, FP we have. We'll first calculate the accuracy. What is accuracy? TP plus TN divided by total sum. So we'll do 50 plus 10 plus 5 plus 100. So we got the answer, 0.90. Next, precision. We know that for these two, precision and recall, the numerator part is TP itself. So 50, no issues. What is the denominator? For the precision, it's the first column, 50 plus 5. We got 909, yeah, 0.90. by 55. Correct. 0.9. We got the precision. What is recall is equal to TP itself. For in the numerator, it's TP. So 50 divided by what? The first row, 50 plus 10, which is 60. We got a 0.833 as the recall. What's the F1 score? Is equal to 2 into, first we'll multiply these two values, this into this in bracket divided by this plus this. We got the value. So this is it. If you know these four formulas, you can directly put those values and find the what question you got. Like you can put the values and you will get the answer. Simple, right?
Can you
Rishabh.
please explain F1 score?
Once more.
F1
Rishabh,
score.
I just have a
Can you please
doubt
explain?
before you. I just have a doubt
Yeah.
before you explain. Would these four values, TP, FN, FP, and TN, would they always be like given in the question, or can there be times wherein they won't give a value and we have to find that?
No, there will be like values. Whether they can do like this, they'll be like find the accuracy and they'll give these three values. They'll say like find TP. Accuracy is, maybe I would say accuracy is 0.90, and they might give these three values and they will ask to find TP. They will give the values. Otherwise, we can't find, right? You will get this. They can be like, there might be a possibility that you won't get this TP or FP, this one. Just a second. Yeah, the thing is that you might get the values, you will get the values, but you might not get these things for the exam. Like you should know that the first one is TP, FN, FP, TN. So basically it's like T. Starting with T, we draw a diagonal like this, TP, TN, and here FP, FN. So once again, I'll explain. So we have four equations, right? Yeah. We have four equations. For accuracy, what's the equation? TP plus TN divided by grand sum. Grand sum means what? Total
Can
sum.
you check when for recall? I think it will be 0.333.
Which one?
Recall.
So for recall, the equation is 50 divided by 50 plus 10. The first row, right? Yes, first row. TP divided by first row. 0.83 is the answer. Precision, TP itself divided by first column. TP plus FP. Recall, TP divided by first row. TP plus Fn. And last F1 score is 2 into precision into record divided by precision plus record. This is it. Just be aware of this table, the structure. Like you should know, like this is TP, this is Fn, this is Fp, this is Tn. Just be aware of this equation too. When you are sorted, there is no issue. That's all about confusion matrix. Now, till now, we have discussed number one, we have discussed what is forecasting, right? So basically predicting future values using past data. There are two types of forecasting methods. First is the regression method. Second is the time series analysis. We have discussed regression methods. We have linear and logistic regression methods. In linear regression, we'll get an independent value and we'll have we need to predict the dependent value. It will be a continuous data. While in logistic regression, the data will be categorical or binary. So we need to find the probability of the same using the sigmoid function. We have also discussed k-fold cross validation. And yeah, now we have discussed confusion matrix. There will be a 2 into 2 matrix given. So first diagonal towards downside, it will be TP, TN, and the other one will be FP, FN. FP, FN. So just be aware of this structure. You will get the you will get any of these four questions. Accuracy, you have TP plus T1 divided by grand sum. Precision, TP. For these both, you will be having TP in the denominator. So TP divided by what? First column, sum of first column. Recall TP divided by sum of first row. We have an F1 score 2 into use this equation. First, you need to find these two values and you use this equation and you'll get the values. Simple. Next, we'll get into time series analysis. So time series analysis, as we discussed, is the second method to make some forecast, right? So there are majorly two methods for forecasting. One is the regression methods. We have already discussed about that. I think what we have discussed till now, except the confusion matrix, we have already discussed in module 2, right? So it will be much easy. So here, it's a new topic, time series analysis. So this is a second method we are learning to find or to predict the data, to predict the future data. So time series analysis involves studying data points collected on or recorded at specific time intervals to understand patterns and forecast future values. So basically, same as the example we discussed in the beginning, there are some data points that like the T seller had. He used those data to find the future value. So basically what he do, he look into the data, he finds some patterns, trends, and he used those conclusions to predict the future one. That's its time series analysis. It's simple. So here we have 6 methods, right? So these 6 methods are types of time series forecasting method. Basically, these 6 are forecasting methods. So we'll be having some data given. We use either of the any of the methods, and we need to find the future value. That's it. We'll be discussing all 6. There are 6. That's a huge number, but all these 6 methods are so simple, so basic. So we'll discuss it fast. First one is the name method. What is a name method? Name method is a simple forecasting technique. I think better I'll show it in the Excel itself. So we have the name method. So what is name method? We have data, right? So Monday to Sunday, we have some data, fine? 10, 15, 20, 25, 30, 35, 40. So someone asked you, predict the data for next Monday using name method. So what will be the value? So here we use the same value that we have on Sunday, just the previous data point. So here it is 40. So we use 40. Fine. Let's take another example. Let's assume there are like day 1, day 2, day 3. Data is 5, 10, 15. Predict the data for day 4. The data will be same as what is there in day 3 or what we got in day 3. So it will be 15 itself. This is name data. Simple method for predicting the future outcome. Simple, right? Like you just need to be aware that we just use the previous data right before the day. Like here it is Sunday, the data is 40. We use Monday, like the 40 itself. That's it. Name method. So this is the first method. Second, we have the seasonal name method. So name method is simple forecasting technique where the forecast for the next period is set equal to the value of the most recent observation. Done. Seasonal name method forecast future values by repeating the value from the same season in the previous cycle. Right. This is also simple. Simply what we do is that, so here we have the seasonal name method. So we need a data for Monday. So what we'll do is that we look at the previous Monday's data. So it is 10. So we use that 10. Fine. So here we use the most recent observation. So here we use the data occurred on the same date in the previous week. So it is 10. We use the same observation, 10 itself. Simple. This is just name and seasonal name methods. So 2 methods are over. In total, there are 6 methods. Next is average method. This is just basic max, just average all the data points and you will get a number which will be the predicted outcome. So if you have 10, 20, 30, 30 plus 20 plus 10, 60 divided by 3, 20. Sum of all observations divided by number of observations. We'll do a question of average too. Weighted average method. There will be some weight assigned. There will be some weight assigned to the values. So weighted average method assigns different weights to past observation when calculating the forecast, giving more importance to recent values. We'll discuss these two. So first method, the naive method, you use the recent observation for the next data for the next day. For the other one, if we want to find the data point for Monday, we look at what data or what sales has occurred in the previous Monday. So we take the same value for the next week. So here we have average method. So what is this? Is equal to, we first sum all these numbers, 110 plus 20 plus 30 plus 40 plus 50 plus 60 plus 70, divided by number of observation, 1, 2, 3, 4, 5, 6, 7. So this is the value. We using average method, we just find the average value of the data. Weighted average method, here what we do is that we assign a weight. So if you get a question like this, what you do is that you assign a weight. So for the recent data, you will give more weight. So let's do like 1, 2, 3, 4, 5, 6, 7. So this is more kind of a weight we giving to each values. For the recent data, we give them like most weight we gave for the recent data. So what we'll do is that we'll multiply 1 into 10 plus the equation is weight into value plus weight 1 into value 1 plus weight 2 into value 2. Like that, we multiply and sum up the whole value. Then we'll divide it by the sum of weight. So here 2 into 20 plus 3 into 30 plus 4 into 40 plus 5 into 50 plus 6 into 60 plus 7 into 70. After this, we divide the whole divided by sum of all these weights. So we have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. This is a weighted average. So 1 into 10, 2 into 20, 3 into 24. Yeah. So for in the exam, mostly you will be getting some weights and some data. So you find the weighted average using this method. Fine. So this is basically the weighted average method. We will weight. There is a weight and there is a value, W1 into X1 into plus W2 into X2 and sum of weights. We get the weighted average value. So first we discussed naive method, seasonal naive method, average method, weighted average method. Next is drift method. So what is drift method? Drift method for forecast future values by assuming a linear trend. Assuming a linear trend continues. Simple. Here we have a data. So 10, 20, 30, 40, 50, 60, 70. So what will be the next data point or observation? Predict that. So we'll take like 10, 20, we have a gap of 10, right? So 30, 20, we have a difference of 10. So the difference is 10 itself, 60, 70. So we predict that the next value will be 80. This is basically drift method. So there is a pattern, there's a linear pattern in the data. So we follow that itself to predict our data. Fine.
The difference will be constant only across all the values.
Yeah, correct. There should be a linear pattern to find the drift data.
You I think you're supposed to take the average increase, right?
Average of the difference.
Yeah, and then add it to the next value
Just a
Like-
second.
to find the next value.
I'll confirm with that.
Yeah, it was
We
called
all-
rate of change, I think.
Yeah, fine. So next we have the exponential smoothing. So exponential smoothing is a time series for forecasting methods that give more weight to recent observation while gradually decreasing the influence of older data. I'll give you guys an example. My Excel is visible, right?
Yes, you.
So here what we do is that we'll be having these three values. We have an alpha, we'll be having an what actual value, we have a predicted value. What we do is that we'll exponential smoothing equation is that alpha into actual value plus 1 minus alpha into predicted value. So you just put all these value into this equation. So 0.5 into what? 100 plus 1 minus 0.5, which is 0.5 into predicted 120. So the value will be 110. This will be our predicted data. The next point or the next observation will be this one. Fine. So we'll be having these three values. This will be given in the question itself. So we take the alpha into actual value plus 1 minus alpha into predicted value. Simple.
Could you please explain that once more?
Fine. So in the question, you will get these three values. You will get an alpha, you will get an actual value, you will get a predicted value. So what you're going to do is that there is an equation for exponential smoothing, which is alpha into actual value plus 1 minus alpha into predicted value. So we have alpha what? 0.5, actual value 100 plus next 1 minus alpha, 1 minus 0.5 into 1 minus 0.5 into predicted value 120. So the answer you get is 110. This is your predicted value. Simple maths, right? You just need to be aware of this equation, alpha into actual value, 1 minus alpha into predicted value, and put those value into the equation and you will get the value. I mean the answer, right?
Okay.
Rishabh, would it be possible for you to cover drift method once again? I couldn't really grasp the formula for it either.
Which method?
Drift method.
Drift method. Yeah. I'll verify that. So next, so till now, we have discussed, initially we discussed forecasting, types of forecasting, methods of forecasting. Then we dive deep into what are the two types of forecasting, regression and time series analysis. In regression, we had two, which are linear regression, logistic regression. We have also learned confusion matrix. So confusion matrix will be asked to find any of the four those values, either the like accuracy, precision, recall, F1 score. Then we moved into the time series analysis, where we learned about 6 methods, right? First one, naive, seasonal naive, average, weighted average, drift, and the last one, exponential smoothing. I'll confirm the drift equation with you guys. Next, we have the last topic. I won't be diving deep into this. I'll just give you a brief idea. So we have autocorrelation and autoregressive. So what is autoregression? So autoregression models uses past data to predict future values. It basically, like as the definition says, it models autoregression models uses past data to predict future values. So what happened before me helps me to guess what will happen next. Same, like we have some data, we use that to predict the future one. Autocorrelation check if there's a pattern in the things that happened before. We have a data, we are finding like whether this data can be used to find a future or to find a prediction or to predict some value. If there is a pattern, some kind of a pattern or a trend in the past data, we find that using the autocorrelation. So basically it is what happened before helps me guess what will happen next. Autocorrelation is like asking whether there are like similar patterns or are today's result similar to what happened before. Like, are there any similar patterns? So taking up a quick example, like the stock charts. So we can use the past price action to predict what will happen in the future. And we can also analyze the past data to find, or the past price chart to find whether there is any similar pattern which is happening in the predicted value also. So here I'll present my Excel. So here we have sales, right? This is for autocorrelation. Here we have a sale. So there is a term named lags. So what we'll do is that this is sales. We have sales. So what we'll do is that we'll keep a lag of 1. So what we are doing is that, so there is a past data. So this is, I guess, the observed one, and this is the expected one. I think so. I actually forgot. So basically, there is a lag we create. So this is basically what we say. We find like whether the past prices or sales have some kind of an effect on the present sales or the future sales. Fine. I'll read out the. So once again, auto-regression helps us to find or predict future data using past data. Auto-correlation checks if there is a similar pattern. Are today's results similar to what happened before? In the Excel example, the previous 100 sale was similar to the current sale, right? So there is a similar pattern. This is all about correlation, auto-correlation and auto-regression. I think completed most part. I'll confirm with the drift equation. So first, once again, we have discussed forecasting. Second, we have discussed the two types of forecasting, regression methods and time series analysis. In regression methods, we majorly had three topics: linear, logistic, and also the confusion matrix. Time series analysis, we majorly have 6 methods. Number 1 is naive, seasonal naive, average, weighted average, drift, and sixth one is exponential smoothing. And lastly, we'll just briefly discussed about the auto correlation and auto regressive. I'll confirm with the drift equation. I think we'll take a break for 10 minutes or 5 or 10 minutes and we'll start solving the sample questions.
Can you show the calculation of weighted average method once?
Yeah, sure.
And can you inform again whether the weights would be given or do we have to assume if they are not given?
I think there was a question in sample paper, either in sample paper or the midterm. I think in that they have already given the weight. I think they will give no in the like the in the module there was a question like this and professor did like one, he gave 1 2 3 4 5 6 7 values. So I just gave this as an example. I think they will give the value, they will give the weight.
Okay, fair.
I think we'll start solving the sample paper at 9:25.
Okay, guys, please share a
Okay.
message on.
This weighted average.
Guys, please share a message on your groups. Like we are starting with question solving at 9:25.
Rishabh, I'm not clear about the autocorrelation and autoregression.
Rishabh, are you there?
Yes.
Alti, go ahead.
What?
Alti, ask the doubt.
Rishabh,
What?
can you please explain autoregression and autocorrelation once? And you said that we'll take a lag. So what we'll do by taking that lag?
Come again once.
Should I repeat?
Yeah.
Okay. So can you please explain once again what is autocorrelation and autoregression?
Right.
And you said that we'll take a lag in that autocorrelation thing.
Yeah.
So
Right.
yeah.
You're on mute, Rishabh.
Am I audible now?
Yes, you're audible.
So auto regression is basically using the past data to find the future values. Fine, simple. We have some past data and we use those to find the future values. Autocorrelation is more kind of predicting a pattern or checking for a pattern. So let's assume, let's assume there is a sales data here and we are saying like in the past it was 100, so next it will be the data, I mean the predicted value is 100, the next after that the observed value is 130, but we have predicted like 120, so there is a pattern here, right? So this is what we call as the lag. I'm not diving deep because I've actually not seen much questions from this side, so I've not given much importance to. So basically this is the lag what I talked about. So we have the same data, we paste it down here. This one gap we give here is the lag. So in this data, we have a lag of 1. So once I paste this one more step down, we have here 2 lags. This is basically what lag is called. I'm not going deep into this. You just be aware of what it is. I think it will be better.
Okay. Okay, thank you.
No, I've not seen any questions from this side too. So I don't know if even if they are asking what kind of questions they ask.
Right, right.
Yeah, I think the drift method, you guys are right. The equation is last value plus average change between observation data that's posted that. Where is it? So drift method forecast is equal to last value plus average change between observations. So here we have last value is equal to 70, average change is equal to 10 plus 10 plus 10. No, like, how should we take the average? Do anyone know that?
Rishabh, I think here the average will come 10 only because the variation is constant. But otherwise, if the variation is different, then the average will result in a different value.
No, we'll take the difference and divide it by what value? Like number of observation will be 7 itself.
Yes, I think.
I think we can start, right? We can start with the sample questions, right?
Yes, sir, we can.
Yes, man. See, the answer will be 50 itself. So I think I've forgot to put one bracket. The answer is 50 for the weighted average method. I will share it once. For the weighted average method, the answer is 50 itself. I forgot to put this bracket out here. You're correct. So in the sample paper, I plan to discuss close to 24 questions. Out of that 24, 7 question, even I have some doubts. I think we'll discuss that in the live session tomorrow. But still, I'll do the problems. I'll do all 24 questions. We can start. Guys, let's start, right? Let's put a thumbs up or something.
Yeah, we can start.
Is my screen visible?
Yeah, Rishabh, it's visible.
Fine. Just a second. Is it visible now? Questions?
Yes, Rishabh, it is visual.
Yeah, Rishabh.
Can you see the Excel right now?
Yes. Yeah.
Yes, Rishabh.
So first question. So we'll start now. First question. Joint probability mass function of two discrete random variable x and y are given as follows. X is equal to y is equal to y. X plus y is equal to 36. Are variables x and y independent? Independent. What's the key term? Independent. In which chapter we have learned about independence? Chapter 1, right? Module 1. First topic we have learned chi-square test of independence. But here, the approach is for the probability one, P of y into P of x is equal to P of probability of both x comma y. So this is the main equation for this question. Main rule. We have to find if P of y into P of x is equal to P of x of y, x and y, then it is independent. If it's not equal, it's not independent. So in this question, we'll find, we know it's given that x plus y divided by 36, right? This is already given. So same like we build a table right here. Y is equal to 1, y is equal to 2. In this question, it's mentioned that x and y belongs to 1, 2, and 3. Fine. Y is equal to 1, y is equal to 2, and y is equal to 3. And we have x is equal to 1, x is equal to 2, and x is equal to 3. Now what we'll do is that we'll equate these values with this. So x plus y is equal to 1, x is equal to 1, x plus y 2 divided by 36. Yes, 2 divided by 36. Y is equal to 2, x is equal to 1, 3 divided by 36. Y is equal to 3, x is equal to 1, 4 divided by 36. Here, what will be the value? X is equal to 2 and y is equal to 1, right? So it will be, basically we are finding the joint probability. So x is equal to 2, y is equal to 1, it will be 3 divided by 36. 4 divided by 36. 5 divided by 36. 4 divided by 36. 5 divided by 36. 6 divided by 36. These are the values, right? So we'll sum all this. Wait. Is equal to we'll find the marginal. I'll do step by step. We'll find the marginal row total. So is equal to sum of these three values. 2, 3, I've done some mistake. 1 plus 1, 2 plus 1, 3 plus 1, 4 divided by 36. 4 plus 4 plus 3, 7, 8, 9. The answer will be 9 divided by 36. Here 3 plus 4, 9, 12 divided by 36. Here the answer will be 15 divided by 36. 15 plus 12, 27, 27 plus 9, the answer will be 1, right? Marginal row total will be 1. Same will do for column. 2 plus 3, 5, 5 plus 4, 9, 9 divided by 36. 3 plus 4, 7, 7 plus 5, 12, 12 divided by 36. And 4 plus 5, 9 plus 6, 15 divided by 36. These both are, no, the sum of these two, this marginal column total and marginal row total is 1. So what we really need to find, so we have these two values, P of Y into P of X. Fine. Okay. Let's take this value 1 by. Just a second, guys. Yeah, basically what we want to do is that first we need to find the expected value. I mean the observed value we have x is equal to 1 comma y is equal to 1. We have this value x1 y1, we have 2 divided by 2 divided by 2 divided by 36. We'll find the expected value 2, right? So 9 by 36 into 9 by 36, 1 by 4 into 1 by 4. So how to find expected value? Marginal row total into marginal column total divided by sum. So we'll do row total is equal to 9 divided by 36, comma, column total is equal to 9 divided by 36. So here we get 1 divided by 18, 2 by 36 equal to 1 by 18, right? Here we'll get 9 by 36 into 9 by 36, which is 1 by 4 into 1 by 4. We'll get 1 divided by 4 into 1 divided by 4. We'll get 1 by 16. So the conclusion is that we found both, like P of X of Y is not equal to P of Y into P of X, since these two values are different. So our conclusion will be simply this is not independent. If it is equal, it is independent. Since these are different values, it is not independent. Are the variables X and Y independent? Yes, that's a wrong answer. No, because the joint is not is equal to product of marginals. Correct. Here, what is the joint probability? The joint probability here is 2 by 36, right? X is equal to 1, Y is equal to 1, 2 by 36. The marginal probability is which we found here. So it's 1 by 16. So these two are different values. So we'll say these are not independent. Thus no, because joint is not equal to product of marginals. Cannot be determined without sample size. Wrong. Only independent when X is equal to Y. Since this is the correct answer, I guess. Number 1B is the answer. No, because joint is not is equal to product of marginals. This is a question from module 1, independence test. We have a sample of 300 employees who own a car among various technologies companies by question on whether they own a car. The response they obtained as follows. But the p-value of this problem is 0.398. Okay, fine. We actually know how to find the degrees of freedom, right? What's the equation for degrees of freedom? Degrees of freedom, D or F, is equal to R minus 1 into R C minus 1. R is the number of rows and C is the number of columns. So here we have 1, 2, 3, 4, 5, 6, 7. 7 columns, 7 minus 1, 6. 2 rows, 2 minus 1, 1. 1 into 6 is 6. So the degrees of freedom is 6. We found the degrees of freedom. Since there is only one option of 6, we can proceed with this and move on to the next question. Right, like it's asked what will be the degrees of freedom for this data set. What is the test statistics to? So we found the degrees of freedom, it is 6. We only have one option, so we'll proceed with this. Equation is number of rows minus 1 into number of columns minus 1. Next question. A marketing team claimed that customers prefer 4 product colors are equally distributed. The survey 200 customers. To test this, they survey 200 customers and get the following responses. There are what is the chi-square test for this data and which data does this correspond to? This term is important. It is equally distributed, right? So we have to find the chi-square test for this data. What is equally distributed means? There is an assumption, right? We have to find the goodness of fit test. So in the option, there are like 2 options for goodness of fitness. Either of these 2 can be the answer, right? So the one thing is sure that we have to find the goodness of fit test. So we'll take the value 600, 55, 40, 60. 65, 55, 40, 60. 65, 55, 40, 60. Fine. N is equal to how much? We have surveyed 200 members. Since it is equally distributed, what we do is that we divide this into 4 parts. 200 divided by 4. Same for this is equal to 200 divided by 4. Basically, this is the observed data. This is the expected. We'll get the same value for other 2. Fine. Now we'll find the deviation. Right, here we have, what's the equation for deviation? Observed minus expected.
Explain again how you got 15.
So in the question, it's mentioned that a marketing team claims that customer preference for 4 products colors are equally distributed, which is uniform distribution. So each expected will be equal. So this 200 customers will divide it into, so we are basically taking like 200 surveys, right? We are conducting a survey for 200 people. So we'll divide this number into 4 equal parts since it's a uniform distribution, since we are assuming that it's uniformly distributed. So we got n is equal to 200. We divide that into 4 equal parts. If there is a 5th variable, we'll divide that into 5 equal parts. So we got the observed, we got the expected. So what's the equation? Like observed minus expected whole square divided by expected. You know that, right? So is equal to observed minus expected. I won't be doing the calculation. I'll be mostly doing mental calculation. So I'll say that 65 minus 50 is 15, right? 15 whole square divided by expected frequency, which is 50. We'll be getting 15 whole square divided by 15, fine. Here we'll be getting observed minus expected 5, right? 5 whole square is 25 divided by expected 50. Again, here we'll be getting 4 minus 50, it's minus 10. Minus 10 whole square, 100 divided by 50. Here again, 100 divided by 50. We'll take the sum for all these values. We are getting 9. What is 9? 9 is the chi-square value, right? That is sum of all observed minus expected whole square divided by expected. The complete sum 2. So what we are getting is 9. There is an answer 9, chi-square goodness of fitness test. We have already found that the answer is 9. But there is one doubt I have in this question. It is given that there are 200 customers, but the sum for all these 4, if we take, it is 220. 60 plus 40, 100, 150, 210, and 5 plus 5, 220. So as per the question 3b. Question 3. As per sample paper, the answer is right, but I don't know what's the logic behind this, because the sum for these 4 values is 220, and we took a survey for 200 customers. So there is a doubt there, but we are getting the right answer still.
Rishabh,
Yeah.
Rishabh?
I just have a doubt over here. Could you explain that part wherein you squared the differences and then divided it by which number? I couldn't grasp that.
Is equal to, no, for observed value minus expected value divided by, this is a equation which we have learned in module 1. Like, what's the step to find the chi-square value? Number 1, we'll be having a table. Number 2, we'll find the expected frequencies. Number 3, what we do, we put those into an equation, right? To find that value, chi-square value. Observed minus expected whole square whole divided by, the square is for the numerator, divided by expected value. This is the equation which we are using here. No, this is actually the same equation which we have used in module 1. Like even for the first 2, like the independence test and the goodness of fit test, we are using this itself, right? The steps are almost similar. So this is the same equation which we are using there. Observed value, which we've already got, since the data is uniformly distributed, we divide it into uniformly distributed, which is equally distributed. We divide that 200 equally. We put those value, the difference, into this equation. I mean, we use this equation and we get the value, the sum as, here is a sum of.
Thanks, Rishabh.
Okay. Sum of. Fourth question. A logistic firm claims that median delivery time for its premium services 24 hours, a quality analysis test by recording delivery times in recorded and random serial 22, 26. Fine. Copy this value to its 22, 26, 24. This question is, we should find the Wilcoxon sign rank test, right? And determine the conclusion. Fine. So we'll do that. We have 22, 26, 24, 30. $28, $23, $25. $27, $29, $31. We have 10 numbers here. I think we'll also give a value A, B, like just for to represent each value. We'll give a name. Yeah. J. These are our values. What is a median? A median is 24, right? 24. First step, we have to find the deviation or the difference, right? So we have a value here, this value minus median, 22 minus median minus 2. It's 24. 26 minus 24, 2. 24 minus 24, 0. 30 minus 24, 6. 4 minus 1, 1. 3. 5. 31 minus 24, 6, 7. See, we got the difference, right? Values. Next, we'll find the absolute value, which is, which is basically, we'll remove all the negatives and just write the number 2, 0, 6, 4. Here minus 1, we'll take 1, 1, 3, 5, 7. Fine. Now what we're gonna do is that this absolute value, we have to give some ranks to them, right? So we'll do that here. So we have, we'll put this in ascending order now. We should not consider the 0 value because there isn't much difference. So we'll not include that. So I'll take the ascending value. We have 1, 1, 2, 2. I'm basically ordering this into the ascending form. 4, 3, 4, 5, 6, 7. And count. Fine. So let's give some ranks to it. 4, 5, 6, 7, 8, 9. Here, since we have repeated numbers, what we have to do is that we have to take the average of ranks. For example, we'll take the average of these two numbers, which is 1 plus 2, 3 divided by 2, 1.5. That will be our rank for 1. We have already discussed this. So 3 plus 4, 7. Since we have two repeating values, it will be 3.5, right? 2, 2.
Rishabh, will we not consider 0 like as the first
No,
rank?
we don't, because since the difference is 0, 24 and 24 are equal, right? So since the difference is 0, we don't actually take those.
All right, got it. Thanks.
Right. We have for number 3, 5, 3, V6, 4, 7, these are the ranks that I'm giving, and these are the values. 7th rank for 5, 8, 6, 9, 7. 5. I think I'm right. Yes. So these are the ranks. So what we're gonna do is that we'll put this new ranks to all our members. Fine. So we have okay. We have these members out there. So for A, the absolute value is 2. 2, what's the rank? 3.5. Fine. 3.5. For B, the absolute value is again 2. What's the value? 3.5 itself. For C, we are not considering him because his difference is 0, right? For D, we have 6. 6's rank is 8. For E, 4, 6. F, the absolute value is 1. For 1, the rank we have given is 1.5. G, the absolute value is again 1. H, 3, 5, will give the value as 5. I, 5. For 5, we are giving the value as 7. And J, 7, we are giving the value as 9. I think I've not made any mistake. Yes. So here is our ranked data, right? So what we'll now do is that we'll put the signs. So we took the absolute value here. Now we'll put the sign. So for A and for F, there are negative signs. We'll put that negative, F, negative. Now we'll find W plus and W minus. W plus is basically all the positive value. Plus, 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 plus. So 40 is 3.586, 1.5, 5, 7, 9. 40 is a W plus value. Okay. W minus value is 3.5 plus 1.5. The sum should be what? 20, 35. Correct. So the W minus is minus 5. So what's a significant, like the critical value for n is equal to 10, the two-tailed test is 8, right? N is equal to 10, two-tailed test is 8. So we'll take the absolute value. We'll see which is the we'll take the mode of both values. It is 40 and 5. Among this, which is the least value, like the smallest one, 5, right? So we compare it that with the critical value for n is 8. So critical value 8 is basically 5 is less than critical value 8. This is a conclusion. Just a second, let me check what happened. My
Rishabh, you're not audible.
Hello? Yeah. No, I'll discuss this later. So I've made a mistake here, some calculation mistake. So for this, the null hypothesis will be we fail to reject the null hypothesis because we get the answer as 9.5 or something. Since it is greater than what the critical value, we fail to reject. I think I'll discuss this later. Question 5. Okay, a company tests the effectiveness of a new training program. No, I think I'll do one thing. Just a second, guys. Harshit,
Yes. Yeah.
I'll send you a file right now. You just share that. Yeah. Okay.
Okay.
No, the thing is that if I'm going like this, you all guys will be also bored. I'll be also having a hard time.
I haven't received any file list of.
What, Harshit?
I haven't received any file.
Yeah, I'm sorry. You got right. No, if the thing is that if I'm discussing like this, it will take too much time. I've practiced all this question on paper, so it's also hard for me to explain like this using Excel. No, I think I'll present the screen with the answer paper and we'll discuss like that. So it would be good for you guys too, I guess. First page.
This one?
Yeah, correct. So here, this is the fourth question we discussed. Basically, the whole process is same. What and all I did was correct. I missed one value. Instead of 23, I put 28, and instead of 28, I put 23. So the values got different. And in the end, we'll get the value as 35.5 for the W plus value and minus 9.5 for the other one, W minus value. Scenes are basically we take my screen, yes. Basically, we take the modulus and we consider the least value out of those two. So we compare that with the 8. We got like we compare it with the critical value. So it is 8 is less than 9.5. Since the critical value is less than 9.5, we failed to reject. We also got the W plus value as 35.5, right? So in the answer sheet, the answer is A. So answer is A, but we are getting 35.5. That's why I've marked re-verify, because I have a doubt for this question because the answers are not matching. So this is one of those question, a doubtful question. I got the answer. This answer is correct actually, but while comparing it with the other one, the answer key, we are not getting the same answer. Harshit, next page. So Harshit, I think I'll send you the questions too.
My screen
Right.
is not visible.
Whose screen?
Are you sharing a screen? It is not
You
visible.
shared the screen, no?
I'm not sharing my screen. No, Harsh, I'll send the PDF to you, the questions. Is it because? Is it because of same values in both? That will not be. We should have sent you the PDF. Question number 5.
Harshit, could you please share those pictures which have those answers and the PDF which contains the questions in that online group? It'll become easier for us to, view it.
Yes, I was sharing this. The PDF and the solution papers.
Harshit, you just now present the 5th question. Sorry guys, I've not prepared myself using solving with Excel, so it's too hard for me to solve using Excel. I've practiced using pen and paper, so it's a bit hard. So a company tests the effectiveness of a new training program by comparing employees' productive score before and after the training. So here, instead of the median, we have two data. One is the after and one is before. So we'll do after minus before, so we get what's the difference, right? The improvement. So using the
Screen is not visible.
No, I'm not sharing the screen. Harshit is screening, right?
Yeah, Harshit's screen is not visible.
That itself, no issues. Harshit,
Yeah, just give me a minute, like sample paper.
Your screen was visible to me. Maybe I could spotlight you so that everyone can see the screen.
yeah, now it's visible. Question 5, yes. So same question, use the Wilcoxon signed rank test. Critical value n is equal to 6, which is for 6, when n is equal to 6, the critical value is 2. What's the sum of positive ranks and the conclusion? Harshit, question 5 answer. What's it? I think you share your screen like you did before. So you can shift between both of them, right? Here also I've written re-verify. Yeah, this is fine. This is fine. Now here also I've written re-verify. Same process, after minus before. Why after minus before? Because we need to like see the the improvements, right? So after minus before, same process, we'll get the difference, we'll get the absolute value, we'll rank them. What is this 1, 2, 3, 4, 5, 6, which I've written in the first column, very first column? That's that I did before A, B, C, D, E, F, G, just to represent who is what. So 1, 2, 3, 4, 5. We given the rank, we have averaged out the ranks, we got the values, we got negative. Harshit, can you zoom a bit? I think we can, yeah, fine. So we got the values. We have both positive and negative values. The ranks. So even in this question, we are failing to reject the null hypothesis, but I'm not getting the exact same answer as the sample paper. In the sample paper, I guess the answer for 5, right? 5 is A. A is W plus is equal to 10 and failed to reject 0. I've asked a few, they also didn't got the answer. This is also a pending question. So question 4 and question 5, we need to recheck once again. Harshit, question 6. Yeah. Monthly salary of a programmer and lines of code written per day by 10 programmers are given in the table. Fine, it is given. What would be the lines of code written by a programmer whose monthly salary is 48,000, beta 1, 4.5? It's a simple linear regression question. Someone asked earlier that whether we'll get linear regression questions. So this is an example for that. So basically we have all the values. The important thing is that what we should predict. We should predict the lines of code written. So our y, or what we have to find, is lines of code written. What is our x here? Our x, or the independent variable, is the salary, right? So simply you do like minus 30 plus 4.5 into 48. So you will get the value as, I think it's 186, right? You can show the answer. Question 6. Yeah, the answer is 186. The most important thing is that for y, we have to consider the lines of code written, right? So x is what? The salary. Fine. Next question. Harshit, question 7. Yeah. So a doctor wants to predict if a... Yeah.
Rishabh, in the 6th question, from where did you take the value 48?
48 in the table, it is written in the other form, right? So basically it was 48,000, but in the table it is written as 32.7, 34.7, and in bracket they mentioned like it is in $1,000. So we divided it by 1,000 to make the value similar to this form. You got that?
Okay, yes.
No, you can take 48,000 itself. There will be just 3 zeros. That's it. A doctor wants to predict if a patient has a heart disease, yes or no. No, based on their age, a logistic regression model gives this equation. Log odds is equal to, so earlier we have already discussed that log odds is equal to what? Linear regression, right? So here we have minus 2 plus 0.05 into age, log odds. What's the predicted probability? for a 40-year-old patient? Yes, answer. So question 7, we have already discussed that log odds is equal to linear equation, which simply that it converts, like linear regression, we have the limit like negative infinity to positive infinity, whereas in logistic regression, we find the probability, right? So we find log of odds. So I think the log of odds value is 0. So 1 plus e raised to 0, e raised to x in the calculator. So we'll get 1 by 2. 1 divided by 1 plus 1 is equal to 1 by 2. Answer is 0.5. I think it's correct itself, right? Yes, the answer is 0.5 itself. 50%.
Rishabh,
Yeah.
question 7 log odds is equal to, there's
Yeah.
where you've done the first formula, there's B0 into what exactly at the towards the right hand side?
Can you take the answer sheet, like Harshit?
Yes, so where there's
Which one?
B0 plus B1 X1. The
Yeah,
first
this is
line is log odds.
basically just I'm representing that log odds is also equal to, that is beta 0. This is the equation for linear regression, right? So log odds is
Yeah.
equal to linear regression, right? So we
Yeah,
have,
but what's that towards the end? Like towards the right hand side, there's this. I don't
which
get it.
one?
What is this over here? I don't know how to point it out. So there's beta 0 plus beta 1 into x1 plus beta 0 into what? What is that?
No, beta 0 plus beta 1 x1 plus beta 2 x2. It continues, right, till beta n
X2.
xn. Yeah, x2.
Okay,
x2.
thank you. Thank you.
Okay, next question, Harshit.
I'm so
Till
sorry
now
to
I-
interrupt, but
Yeah.
how did you calculate log odds here?
Log odds, we have to use the calculator, ln function. You were there in the last session, right?
Yeah, I was there. I'm
No,
just a little bit confused.
I think ln function, what, can you show the question once more, Harshit? I'll explain something. So here we have minus 2 plus 0.05 into age, right? What's the age? Age is 40. 40 into 0.05 is equal to 202, right? Minus 2 plus 2 is equal to 0. So we have to find log odds is basically 0. We got the value of log odds already, right? You got me?
Yes.
Yeah. So what's the equation? Like 1 by 1 plus e raised to minus log odds. That's the equation. So we directly put that value 1 by 1 plus e raised to minus 0. So we'll get the answer as, I think, 1. So 1 divided by 1 plus 1, 1 by 2, which is equal to 0.5, 50% chance.
Okay, Rishabh, thank you so much.
Next question, Harshit. Right. Again, which one is this? Yeah, cool. This we have done in the last session, I guess. We got different answers, but still, a hospital wants to predict a patient is at a high risk of admission. Length of stay is there. Number of chronic condition. What are those? Those are the independent variables. Predict what the hospital wants to predict. Y is equal to high risk of admission, right? So Y is equal to high risk of admission. Length of stay is x1, beta, yeah, x1, and number of chronic condition is equal to x2. Same logistic regression. Yeah, same logistic regression model. We have to find first linear regression or log odds. We have to find beta 0 plus beta 1 into x1, which is 6, right? Who stayed? Harshit, you take the answer sheet. And then we have to find beta 2 into x2. We have done this in the last session. We'll get very different answer, but the correct answer is option A. Yeah. Can you take the next page? This is the log odds. We got log odds as minus 0.7. Yeah, from there we found the logistic regression 1 plus 1 divided by 1 plus e raised to log odds, right? Then we'll get 0.332, 33% probability. But in the options, there are no, like we don't have any options with 33.22, but the closest is option A. The answer is also option A itself, 37.8. I think like I'll mention like in total till now we have like 3, 1, 2, 3. Including this, we have 4 questions which we need to recheck once again. Yeah, you can show the next question, Harsh. So this is also something which we need to recheck. This is simple. We have discussed today what is the F1 score, right? Yeah, in this question, they didn't give what is the TP, where is the TP, FN, FP and all. So the first box, the first 50, that 50 is what? TP. 10 is what? FN. 20 FP, 120 TN. We have to find the F1 score. F1 score is equal to 2 into precision into recall whole divided by recall plus precision. So first we have to find the precision, which is TP divided by first column. Then we have to find the recall, TP divided by first row, sum of first row. Put it that into the equation. Harshit, please share the question 9 solution. Yeah, this is it. We'll get, can you scroll down? Yeah, we are getting 0.76. Is there any option like that? Yeah, 0.77. That's the answer, I guess. B, question 9B. Yeah, that's the right answer. Next question. Company analyzes its quarterly sales data. What is the seasonality index? Actually, I haven't discussed this to you guys. The equation for this is, no, yeah, we can. So we want the seasonality index for Q4. So the equation is average of Q4, those four values average we have to take and divided by total average. As mentioned, we have to recheck this question once more because the answers are not matching. So average of Q4 and average of total average will get 1.24, but the answer is something different. Will be something different. Question 10. You can show that question, right? Harshit. Harshit, you can show the question. The answer they've given is 1.28. What I'm getting is 1.24. Basically, this Q4, right? We'll take the average of 130, 140, 135 and hold that average divided by the average of all the data. So we'll include all this data divided by 12. We'll get the average of the whole data. I'm getting 1.25, but it's mentioned 1.28, so I don't know actually. So this is the 5th question which we need to recheck. Next. Exponential smoothing, simple, right? We have discussed what is the equation, alpha into actual value plus 1 minus alpha into predicted value. What's the, yeah, Grahesh, please.
I wanted to know what like which section would this kind of question be in? Because it seems like it is very easy. So would this be like a 2-marker question or on the third section with like the 5-marker questions?
Which one are you mentioning? This question, 11th
This
question.
question. Yeah.
I think this can be a 2 or 3 mark question, right? No, I think for the 5-mark question, I think it'll be mostly a good. The Wilcoxon one, it should be 5 marks.
Yeah.
Goodness of fit test and the chi-square one can be 5 marks, and
Even the
I
regression one.
yeah, even the regression. I don't think I don't think so. It's simple maths, right?
Yeah. Just put
So
the
for
formula.
this, yeah. So for this, we'll get actual sales is 120. 120 into 0.4, which will be 4.48, I guess, right? 12 fours are 48. 48 plus 60. 100 into 0.6. So we'll get 108. 108 is the answer. Equation is alpha into actual sales plus 1 minus alpha into predicted sales. Fine. So we'll get the first part as 48, second part 60, 108. Next question. Harshit, next question. Yeah, simple average method, basic max, one, just sum up everything, divided it by n, you get the value 100, 200, 300, 400, 500, 520, 570, 600, 640, 700. 700 divided by 5 and 14, 140. Simple average method. This we have discussed under the time series analysis, right? Naive, seasonal naive, average, weighted average. Next question. The answer is 140. Yeah, weighted average. Yeah, this is an example for weighted average question. So here we already have the weights. Yeah. Here we have, this is a tricky question. The way they like ordered the data is a bit tricky. See, initially we have, so for week t minus 1, we have 0.58. T minus 2, we have 0.3. T minus 3, we have weight 0.2. But when it comes to units, they're starting with T minus 3. Right. So we should be more aware of these kind of things. So it's basically easy. We just need to do weight into unit, number of units, sum up everything divided by, it will be 1, I guess. The sum of weight will be 1. So you can show the solution, Harshit, if you want. I think the previous page. Yeah, yes. So 0.5 into 250, we got 125, 66. We sum up everything, 231. The sum of all weight is 1. So here in this question, we already got the weight, right? So I think in exam 2, we'll get the weight. So 231 divided by 1, sum of weight is 1, which is 231 itself. Next question. Yes. So after 13th question, we are jumping on to 17th question. 14, 15, 16 questions are from module 4. So we are not discussing here. In logistic regression, fine. The logic function is defined as this. Okay. What is the primary purpose of this transformation? Fine. We already know one thing, right? Log of this is equal to linear regression. So linear regression. So what is the characteristic of linear regression? In linear regression, the value can take any values between negative infinity to positive infinity, right? So here they said, what's the primary purpose of this transformation? So number one, we know log p of 1 minus p is equal to, yeah, log p of 1 minus p is equal to linear regression, beta 0 plus beta 1 into x1, that equation, we know the characteristics of linear regression, which is it can take any values from negative infinity to positive infinity. So on this basis, I'm getting the answer as B to model a linear relationship between predictors and probability. Linear relationship between predictors means variables and probability. Basically, we are converting this probability term into a linear form or a variable form. But here in the answer sheet, I think they gave option C as answer. So I don't know. This is also one question which we need to recheck. No, you guys have any thoughts? Like this is the basis on which I solved this question. But I don't think you can jump into next question then. This is a sixth question, I think, which we need to include in that recheck category. Next question. Yeah, next question. I think so. I've solved that on that basis. I don't know whether I'm right or wrong. I think these 7 questions we'll discuss in tomorrow's session, faculty live session. Which of the following is not an assumption of logistic regression? Simple. We have already learned 5 assumptions of linear regression, right? So what is that? Learning is not hard. Notice now linearity, independence, homozygosity, normal distribution, and last 10, no collinearity. Dependent variables binary. Yes, it is binary. Predictors are linearly related to the log odds. Correct. We have just mentioned this is the above thing, right? Residuals must be normally distributed. Normally distributed is the assumption of which one? The other one, linear regression. So option C is the answer. Next. Yeah. This I've solved. Here what I did was that the question is logistic output of a logistic regression model binary problem. We have a equation here. How would you interpret the coefficient of x? So basically, I've equated the equation with x is equal to 1 and x is equal to 2. Then I saw that the values are increasing. As x increases, the overall probability also increasing. So my answer was option by 50. Second, I think I've can you show the answer sheet? No, my answer was second, option B. Which one? 20. Yeah, there is an increase, right? No, here I took 1, here I took 2. There is an increase. This and the previous question, no, 18th question. Those are somehow related. That's why I put that here. So I think the answer is B. 20 in answer sheet 2, the answer is B. I think that's correct. Yeah, next one. No, the basis on which I solved the question, that's the thing. I'm not sure that whether the approach is right, but while I equated it with x is equal to 1 and x is equal to 2, I'm getting that the overall probability is increasing. So this question, I don't know the answer, honestly.
Have you skipped 18th question?
Which one?
18th.
18th.
Yes.
Harshit, question 18, please. Oh, yeah. Okay. In a simple linear regression model, what does the slope coefficient beta 1 represent? Yeah, correct. See, what is this? Beta 1 is coefficient. X is the independent variable, right? X is the independent variable, right? So beta 1, if we put some value for beta, the overall RHS side increases. So yes, it's B, the change in Y for a unit, 1 unit increase in X, holding all else constant. As RHS increases, Y2 increases. Yes, correct. Option B. Next question, 21, I guess. 22, 22. 21 also, we need to recheck. I think I have the list in total till module 3. I have 7 questions that I want to re-verify again. So yeah. What's the key distinction between parametric and non-parametric test? Fine. What's the key difference? Parametric test requires distributional assumptions, correct? While non-parametric tests do not, correct? Non-parametric tests always have higher statistical power, no? Categorical data, no? Option A is the right answer. Because, see, that's in the question itself, right? Parametry means there is some parameter or assumptions that's holding that. So while non-parametric, we are not taking any assumptions. We have a method and we are like the answer is not backed by any assumptions. So that's non-parametric test. The answer is A. Next question. Yeah, which of the following is the non-parametric alternative to paired t-test? We have discussed this in the last session. Please answer, guys. Simple, right? Correct. B, correct. So the two features I think which I've discussed is Wilcoxon signed rank test. Yeah, it's used to relate two samples. Correct. It's used to find the relationship between two samples, and number 2, it's an alternative to paired t-test or t-test. Next question, Harshit. So the answer is Wilcoxon. Next. Harshit? I think 24, right?
Yeah. You said like next.
Like we discussed 22 or not? 23, I mean 23. Which of the following is it? Yeah, fine. 24 next. 24. Yeah, also out of all this, only one is a non-parametric test. So even if we don't know the substitute to p-tables. Yeah, correct. You are right. Right. Which of the following is a parametric test? Which is the following is the parametric test? Same as the question we discussed before. Correct. T-test. Right. Independent sample t-test. This man with me and all, it's I haven't heard those in the modules, but those are there in the handout. Full one handout there in man with me U-test and all. I don't remember whether those were in the modules. The answer is independent sample t-test. It's a parametric test, right? We've discussed just now. Next question, Ashrit. In the Wilcoxon signed rank test, how are type differences handled? Yeah, we have like the only one question we did for Wilcoxon. I've said right what we did. What we did, we got a difference of 0. Correct. B. A B. No, not B. No, what we did, we got 24 minus 24 is equal to 0. What we did, yeah, that
We did not consider it only.
exactly. They are excluded from the analysis. Correct. Right. Fine. Next question, Ashik. What is the null? See, what's this? can you show the previous question, Harshit? 25th. Okay, fine. Sorry. Okay, they are treated as zero difference. Next question, sir. What is the null hypothesis of the Wilcoxon-Signed-Rank test? What is it? There can be two null hypotheses. One is that only three options for this question. I think I've missed the last one, right? No, the thing is that first assumption, the null hypothesis will be the difference between the data will be zero. The second one will be the difference won't be zero. So I think I'll read out the question. 25, 26. The median difference between pairs is zero. Correct. That's the answer. There are 5 options. E is the answer. The median difference between pairs is zero. What's the alternative hypothesis? The median difference between pairs is not zero. Yeah, next question. Last question, right? 27. Which forecasting method would you choose for a data with no trend or seasonality but occasional outliers? Actually, occasional outliers. I don't know on what basis we have to answer this. I actually don't know. Answer is, I guess it's E or something. What's the answer? I think it's exponential, right? No, it's 25, it's B. It's 27, right? 27, it's E. Do anyone know like why it is E? Grahesh, Rishmi, Alvin? Any idea of why it is E?
I guess it's kind of in the question, no? Because every other method depends upon seasonality a little bit.
But occasional outliers. I think this is also we should ask in total. I'll say the question number so you can note, right? So you can also ask in tomorrow's session.
Are we sure that the answer is E, exponential smoothing method?
Why it is so? No answer. Oh, like that. No, in the answer sheet it's shown as E.
Oh, okay.
We don't know what's the basis on which we should conclude that. So I would say in total we have discussed 24 questions, and out of which, if you want to note down, you guys can note down. Question 4, 5, 8, 10, 17, and 21, and 27 also. These are questions which we need to re-verify once again. For every method, this method depends on seasonalities. So that's it, guys. Out of 24 questions, I think almost 8 questions we have to re-verify once again. So 16 questions we have discussed completely. So sorry that I've not prepared myself to do this in Excel, to be honest. I've solved in using pen and paper, so I couldn't. I mean, I couldn't do those practical questions. I think we can conclude, right? You guys have any doubts or like something? We have 22 participants.
Hi, am I audible?
Yeah, you are.
Okay, so I had a doubt. When we do Wilcoxon test,
Fine.
so what value do we compare with
Mhm.
the critical value? Is it always the smaller value among the W plus and W minus?
Yeah, it is the smaller value. First, what you do is that you will get two values, right? W plus, W minus. You take the mod of it. So it is negative free, right? Both will be positive values. Out of that, you take the least value and compare it with the critical value.
Okay, and like if there are values given in the question like before and after, it's always after values minus the before values.
Correct, correct.
Right. Okay, thank you.
Fine.
Rishabh, in second or third question, I guess we used the goodness of fit test. That was just
Mhm.
because in the question equal distribution was written.
Can you
Well
come again,
distributed, I
Arpit?
think.
Fourth
Yeah, I'm
question?
saying that in second or third question, I guess, we
Mhm.
used the goodness of a test, and you said that we used it because the equally distributed was written. Remember?
1 second.
Wait,
I'll
I'll-
advance. I think this question, right? This or this one? This one?
third one, yes.
Here, what's the problem?
We used here goodness of a test because equal distributed was mentioned in the question. That's why.
Yeah, we've distributed equally. Yes.
That's why we used goodness of a test and not chi-square test of independence.
No, the question is a marketing team claims that customer preference for four products are equally distributed, right? They claim that the data is distributed. So we will revise once again. For what we use chi-square test of independence. Why? To test whether two samples are independent, right? We use goodness of fit test to test whether the data is distributed as said. So here it is mentioning that the marketing team claimed that it is equally distributed. So we have to find whether it is actually equally distributed or not. So that's the main purpose of goodness of fit test, right?
Yes, yes. Okay, thank you so much.
So here also one problem is actually there.
Yeah,
Like
that's
I
the total
mentioned,
one.
yeah, but we are anyway getting the answer 9 itself.
Yeah.
Rishabh, am I audible?
Yeah, you are.
I wanted to ask that while I was hearing the live session for module 2, the
Mhm.
instructor said that while we use the Wilcoxon test, when
Mhm.
we consider like we are given with the two conditions like pre and post or something like that, we basically only consider the positive Wilcoxon ranks while we compare it with the critical value. Is it like I might be wrong? It's just a doubt that I have.
No, who said this?
I think it was some some Prabhu something. I mean, while I was listening to the live session recording, there
No,
was a question in midterm
if
or
that's the case, we should confirm with that.
okay, like okay, I'll confirm.
Okay. No, tomorrow we have a session, right? We'll discuss it.
Yeah, sure.
No, even the session that you conducted, he also mentioned that we have to take the least value. And before that too, I've learned like we should take the least value. So I don't know whether
Yeah,
it's
even majorly whenever I'm solving, it's mostly the least value cases only. But when I was listening to it yesterday, I might have got confused or something. So
fine. We'll ask there. We'll ask. That's it, I guess. Here we have like 8 doubts. And like she mentioned, we should also ask that and this one too, this question 3. Why is it like this? Yeah, that's it. I think it's fine. So sorry that I couldn't do the practical session because, as I mentioned, I didn't practice using Excel, so it was hard. So let's conclude on what. First time we are finishing off a session within 3 hours. I thought it will take more than this. Harshit, should we conclude?
Yeah, like Mansi asked for the CLA of economic solution. So I can go ahead with that. If you want to leave, you can.
Yeah, fine then.
Yeah, and guys,
Mansi, are you there?
She's coming, like joining.
I just
Guys,
wanted to
please.
ask that for the fourth module, we'll have it before the life faculty session.
Live session. Yeah, actually we're planned. You will be taking module 4 tomorrow. Timing will be somewhat late because we have the faculty live session too, right? He told like he need 1.5 hours. In that session, we'll discuss the other 6 questions too. Yeah, we'll be having tomorrow. I think by tomorrow we'll be ending all our live sessions, right? Yeah. After that, we won't be.
The IKS module 5 is remaining, like we have to complete it.
Okay, fine.
Yeah.
Yeah, we will be having module 4. You will be taking tomorrow. It will be a shorter session, 1.5 hour session.
Okay.
Maximum. He told like maximum he need 1.5 hours, so it will be a short session.
Okay.
Thanks, Aaron. So I think we can conclude with statistics. I'll briefly revise everything. Module 1, 3 topics. I would say 4 topics. Parametric test, you should have some idea what is parametric and non-parametric test, because we have a lot of theory, right? So that's one topic. Second, chi-square test for independence. Third, goodness of fit test using chi-square. Fourth, Wilcoxon sign rank test. Module 2, linear regression, logistic regression. Under linear regression, we have the assumptions too. And third, non-linear regression. Module 3, simple, started with forecasting, linear, logistic regression, confusion metrics, which is important. I think from confusion metrics onwards, those are new topics. So confusion metrics, and the other one is time series analysis, right? Under time series analysis, we have 6 methods. Number 1, name, signal name, average, weighted average. 5th one is drift method. Drift method, I've made a mistake where I told something else, but the right thing is you share. You take the last value plus the average change between observations. That's the value you should add. That's the value you will get, the predicted value you should get. So that's drift method. And what after that? Yeah, drift method, exponential smoothing method, and lastly we'll discuss autocorrelation and autoregression. I think just revise everything and that's it. Yeah. Yeah, I think we can end the statistics session. If anyone want to, the microeconomics, right? Yeah, if you guys want, you can stay back. Otherwise, you guys can leave, no issues.
Guys, please do practice the calculator, the Tata Ion, but do not heavily practice on that because you are not getting the keyboard. You have to enter all the value by the mouse. So it is not easy to put all values in a little bit time.
Yeah, it's no, even in the Tata Ion calculator, even I have to use my mouse to enter the values. So it would be a good practice.
Just if you want to enter 58,000 and 58 then triple zeros, so it will take time. So don't heavily depend on the calculator. Use it when it's ready to use.
Is asking, with revising all the modules and what you have taught, can I score some good marks?
He can. But I don't know I can or not. This time you have to teach me again. Activity,